Now base 2 and base 16 are common bases, not nearly as common as base 10, but they're still common. But we can do this because of the pattern is exactly the same. We can do this with any base, bases that are not used at all. So let's do a base 7, which nobody uses, right? But we can identify what digits are allowed. The digits would be 0 to 1 less than 7, which is 6. So those are the allowed digits. And we can identify the place values for this, right? So the place values are going to be, we always start with the ones place on the far right. So that's 7 to 0 is the one place, and 7 to 1. So this is really straightforward to do with any base number. And you can figure out those place values. Once you have the place values figured out, then you can do what is called the decimal expansion of the numbers. And another way to say this is you're converting it from whatever base it is to base 10. So something that we can work with. We really don't have, there's not much that we can do. Oops, I'm not getting that. I'm trying to talk and do this at the same time. Doesn't work so well. Okay, so we can do this with any base that we want to work with. And then to do the decimal expansion is you use these place values. So let's do a decimal expansion of a base 2 number. So base 2 number would look something like this, except it wouldn't be all superscripted. Okay, so that would be a base 2 number. So let me go ahead and put these all in the places where they are, right? So I'm just going to expand it each to be in the place value. And I could do that. Oh, let me go back and show you. This is really important. How do we tell that that is not place 10? In fact, we can't. This is 10,110. That's that number. If I want this to be a base 2 number, I have to say it. With base 10, I don't have to say it, but with every other base, I need to either put a subscript that says the base, or I need to say it in parentheses, base 2. Because otherwise it's just a base 10 number. So now that I've made it a base 2 number, really important to put that subscript on. I can go ahead and do the expansion, the decimal expansion, so convert it to a decimal number. And the way that I do that, again, is to work with these place values, right? And so this is going to be a base 2 number, and each of them are in their specific place. So let's go ahead and we can write this up. This is 1 times 2 to the 4. Now I'm not going to write it out. Well, I'll write it out the first time, but after that I'm not going to write it out because it just takes a long time to write it when I can do it in, you can often do it in your head. So we have 1 times 2 to the 4th, right? 2 to the 4th. And then you do the plus. And then it's a 0, right? You do the digit, 0 times 2 to the 3rd. And then plus 1. And you get the idea of how you write this out. 2 to the 2. Now, when we're doing this, oops. And this is why I'm not going to do this very often, because writing it out just takes a great deal of time. And then it's 1 times 2 to the 1. And this is a 0 times 2 to the 0. Okay, this is the base 10 expansion. Because what we're doing here is we're going to convert it to base 10. So now when we do these calculations, they will be base 10 calculations. And so we look at each digit. And so we've got 1 times 2 to the 4th, and 2 to the 4th is 16. So it's 1 times 16. This is the really cool thing about binary. You're always multiplying by 1 or 0, which is awesome. So 16 plus 0 times 8, right? 2 to the third is 8, but since it's 0, we're always just going to have 0, plus 1 times 2 to the second power, which is 4, so 1 times 4, plus 1 times 2 to the first power, and 2 to the first power is 2, so that's 1 times 2, which is 2, plus 0 times 2 to the 0. We'll multiply 0, we always get 0. So there's our, we took the multiplication, right? We expanded them based on the place values, did the calculation, the digit times the place value, and we came up with these numbers. And these numbers are base 10 numbers, and now we can simply add them up, and we get 16 plus 4 plus 2, which is 22. And that's a base 10 number. So we've expanded it and converted it to decimal. So now what this is really saying is this binary number, 10110, base 2, is equal to 22. And the 22 is base 10, so we won't use any subscript at all. There you go. We've converted a base 2 number, binary, to a base 10 number, decimal.